Friday we talked about different uses of variables. We looked at several of them. We said there was one left to look at, and that's what we're going to focus on today. Is what happens with the use of a variable that looks something like this. A variable equals a number. Now we've worked with these enough, we know that is called an equation. Called an equation. And the key to that equation is this symbol right here, the equal sign. If I ask you to define what that symbol means, we all know what it means, but it's difficult to put it in words, especially without using the word equal. So often, what looks so simple can be tough to kind of verbalize. What it really means is what's on one side has the same value, exactly the same value as the other side. We can actually think of it like a balanced scale. What's on one side of the scale exactly balances the other side. So it balances around that equal sign. All equations start out in this form, as a variable equals a number or a number equals a variable. And they are built up from there. They can be built up with any of our basic operations. Addition, subtraction, multiplication, division, powers and roots. Ones that we won't get into, but we know exist, are exponentials, logarithms, trig functions, and their inverses. Any mathematical function can be used to build up an equation. So here, we're just going to pick something. Let's add 7. So if I add 7 here, I get x plus 7. I have built up that equation. Now, if I just add 7 to the one side, this is going to tip unless I do the exact same thing to the other side of the equation, or the scale, if you want to call it that, to keep it balanced. So on the other side, 4 plus 7 is 11. So we have now built a more complex equation. Now in math, we're not very often asked to build an equation. Typically what we're asked to do is to solve an equation. We're asked to solve an equation, what it's asking us to do is to take it apart and get back to this initial form of a variable equals a number. So here, this was built by adding 7. To take it apart, we're going to do the opposite. We're going to subtract 7. By subtracting 7, it removes that piece, that plus 7 there, leaving us with just x. Now again, it's a balanced scale. If I subtract 7 from one side, it's going to tip unless I do the exact same thing to both sides. So I subtract 7 from the other side of the equal sign as well. 11 minus 7 is 4. So we are back to that form of x equals 4. Now the rules we talked about in the first week of addition, subtraction, multiplication, division still apply here. In this case, we were adding or subtracting. Notice we only did it to one piece, one digit on each side. We subtracted the 7 from the positive 7. We didn't touch the x because it didn't have the same name. When we add or subtract, we have to have the same name. So that means we line things up and only work with the stuff with the same place value, same name. When we multiply or divide an equation, we don't need the same name. So we have to make sure we multiply or divide every piece of that equation. We'll see that. So here, this equation, we built it. So we knew it was built by adding 7. So we knew that we could take it apart by subtracting 7. The trick to solving an equation is being able to look at it and know how it was built. So if we have 9 equals y minus 5. Figure out how that equation was built. We locate the equal sign. Well, it's right there. Then we look at the side as the variable on it. That would be the right side in this equation. Then we ask ourselves, what is keeping the variable from being by itself? Here it's the 5, and we ask, how is that 5 attached? Well, remember, we have to use one of our basic operations. The 5 was attached by subtracting it. So when we look at how this equation was built, what was done to the variable, in this case, what was done to y, was 5 was subtracted from it. So we know that to solve it, to take it apart, we do the opposite of subtracting 5 is adding 5. Again, we're adding, so we only have to do it to one digit on each side. So we move the negative 5 over there. But we do have to add 5 to the left side as well to keep it balanced. 9 plus 5 is 14, and on the right side, we're left with just y. So 14 equals y, or y equals 14. So once again, we're down to a variable equals a number, or a number equals a variable. We might have 8x equals 32. Here again, we find the equal sign, which is right there. And we ask, what's been done to our variable? What's keeping our variable from being alone here? There's the 8, and the 8 is multiplying x. So what was done to the variable, in this case, what was done to x, it was multiplied by 8. So to take it apart, we're going to do the opposite. We're going to divide by 8. Now notice there's only one digit on the left side, so I divide that by 8, cancels out the 8x, the 8 and the 8x, giving me just x, or 1x, which is just x. There's only one digit on the right side, so I divide that by 8. 32 divided by 8 is 4. I shouldn't say one digit, there's only one item on the right side, divided by the 4. Well, these were pretty simple because there was only one piece built onto them. But we can run into something like 3z minus 5 equals 34. So here we find the equal sign, it's right there. Variable is on the right side over here, the z. We ask what was done to z to build this equation. Well, it's been multiplied by 3, and then 5 has been subtracted. Order of operations says we multiply before we subtract. So when this was built, z was multiplied by 3, then the 5 was subtracted. Now when we go to take this apart, think of putting together a piece of furniture or a bottle or whatever. You've just finished putting it together. You put on the last piece. You need to take it apart. The first piece you're going to take off is that last piece you put on. So here the last piece that was put on was the subtracting 5. First piece we're going to take off is the subtracting 5. We're going to remove it by adding 5. Again, we're adding, so we only have to do it to one item on each side. We add 5 to get rid of the negative 5 on the right side. We add 5 to the 34 on the left side to get 39. Right side, we still have the 3z. Next, we'll get rid of the multiplying by 3. That's the last piece. Get rid of it by dividing by 3. Again, there's only one item left on each side, so we divide them. 39 divided by 3 is 13. And 3z divided by 3, well, the 3's cancel out. That's 1z or just z. 13 equals z. If you're not confident in your answers at this point, you can always double check by going back to the original equation and replacing the variable with the number we got as our solution. So 34 equals 3z is going to become 3 times 13. We replace z with the number 13. So the minus 5. Then we just need to make sure we get the same value on each side. Well, we already have 34 on the left side. That's all there is. We need to check, do our order of operations to simplify and see if we have 34 on the right side. 3 times 13 is 39. 39 minus 5 is 34. So we also have 34 on the right side. So getting the same number, we're relatively sure we did that correctly. Now, I realize most of you have been through algebra, so you've seen this before. So I'm going to go up through the progression kind of quickly to get to more difficult equations. Now, we might have something like 13 minus 2x 7. This one doesn't look like it's a lot more complicated, but it is, and it comes down to that one of those very initial steps of figuring out what has been done to x. Most people look at this equation, they think there's been subtraction. There has not been subtraction here. If you look what was done to x, x was multiplied by -2. And then the 13 is positive, so the 13 has been added to it. Now when we go to take this apart, last piece put on was adding 13, so the first piece we take off is we're going to subtract 13. Well, 13 minus 13 just removes the 13 on the left side. What we're left with there is a -2x. On the right side, 7 minus 13 is a -6. Now all that's left is the multiplying by, it wasn't by 2, is by -2. I forgot to write that in there. Multiplied by a -2. So we have to divide by a -2. That -2 is gone on the left side, leaving us with x. -6 divided by -2 is a +3 on the right side. So x equals 3. Again, we can double check this. Let's go back to this original equation and rewrite it. 13 minus 2x is going to become 2 times 3 equals 7. Now we have 7 on the right side. Nothing to do there. We need to make sure when we combine things on the left side, we also end up with 7. Order of operations says we multiply first, so 2 times 3 is 6. 13 minus 6 is 7. So we do get 7 equals 7. Well, let's get up to something a little bit more complex than that. Something like this. Look at this one, we find where the equal sign is. Well, there it is. We identify where the variable is. It's on the left side, but we see the variable occurs twice. We can solve an equation. There are steps we need to take. Step 1 is always going to be combine anything that we can on each side. Here, we can combine the 5x and the 2x. If you think about this, I'm going back to the idea of the balanced scale. 5x and the 2x are on the same side of the scale. So if I just push them together and make one big pile of x's, 5x and 2x make 7x, it's not going to change the way the scale balances. I still have the -8 or -8 there, equals 34 on the other side. So because the 5x and 2x are on the same side of the equation, I just combined them. That's my first step. If possible, combine anything I can on each side. Next, I'm ready to solve. I add the 8. 7x equals 34 plus 8 is 42. And we can divide by the 7. X equals 42 divided by 7 is 6. And again, we can go back up here and we can double check this. 5 times x will become 5 times 6. Minus 8 plus 2 times x will become 2 times 6. Or 5 times 6 is 30. 8 plus 2 times 6 is 12 equals 34. 30 minus 8 is 22. Plus 12 is 34. We get 34 on both sides. Similar to that one, but slightly different, is this equation. Here we find the equal sign. Well, there it is. We look to see which side the variable's on, and we see that the variable is on both sides. This is the second thing we might have to do before we solve, and that is get the variable on one side. And the equation is already there, it's already on just one side, but here there's a variable on both sides. We can't just push them together because they're on opposite sides of the equation. Only way we can get it to one side is just to take one of them and get rid of it. Mathematically, how we get rid of something? Well, if it's positive, subtract it. If it's negative, we would add it. Which one do we get rid of? Well, generally the smaller of the two. We have 5x and 2x. 2x is the smaller one, so we're going to get rid of the 2x. Positive, so we're going to get rid of it by subtracting 2x. That makes that go away on the right side. Now remember, we have to subtract 2x from the other side as well. Because we're adding or subtracting, we only have to do it to one piece. And that would be the 5x because it has the same name. Now on the left side, we have 5x minus 2x is 3x. Have the negative 9 equals, have the 27 there. Now, we have the variable to one side. We've already combined everything. Nothing to combine. We're ready to solve it. So we're going to add 9. 3x equals 27 plus 9 is 36. And we divide by 3. Now, there's a couple of things I've started to skip here. One is I haven't been writing out what was done to the variable to figure out how to solve it. I'm going to assume you guys can do that part or figure out what steps need to be taken to solve it at this point. If you struggle with that, let me know and I'd be happy to start doing that again. The other thing I'm not going to do anymore is I'm not going to keep plugging it back in, plugging the answer back in and double checking to make sure I get the same value on each side. The next thing we can do that complicates an equation is something like this. Five times 3x minus 4 in parentheses equals 55. Whenever we see parentheses, whether it's in an equation like this or an order of operations, it should always scream at us, do something here first. Whenever we see the parentheses, the first thing we should check is to see if there's anything we need to do inside the parentheses. Here, there's not. 3x minus 4, there's nothing we can combine with that. So then the next thing we need to do is to see if there's anything that needs to be done to the parentheses. And here there is. The parentheses are being multiplied by 5. So 5 times 3x, 15x. 5 times negative 4 is a negative 20. Right side is still 55. So what we just did there is kind of that first step we talked about, combining what we can on each side. Doing that distributing or multiplying by the 5 is just combining on the left side. Now we're ready to solve this just like any other equation. Add the 20. So on the left side, we have 15x. The negative 20 is gone. On the right side, 55 plus 20 is 75. Next, divide by the 15. Get rid of the 15, leaving us with just 1x or just x. 75 divided by 15 is 5. X equals 5. Any questions there? So we can step these up to be more or less difficult. let's try something like 8 times 2x minus 7 plus 11 equals 35. So here, again, we see the parentheses. So it should draw us to do something there first. There is nothing to do inside the parentheses. 2x minus 7 can't be combined. So we look to see what needs to be done to the parentheses. And here we have multiplied by 8. So let's do that. 8 times the 2x, 16x. 8 times the negative 7 is a negative 56. Now the parentheses end here, so the 11 is not multiplied. The 11 is just going to stay as it is. I'm going to keep combining on the left side because I have a negative 56 and a positive 11. So the 16x isn't affected. Negative 56 and positive 11 gives us a negative 45. On the right side, well, the 35, there's nothing to do there, so the 35 has not changed at all. We have combined everything we need to combine. The variable is already on one side, so we can go ahead and solve. Add 45 to both sides. Minus 45 is gone on the left, giving us 16x. On the right side, 35 plus 45 is 80. And now we'll divide by the 16. X equals 5. Look at something like this. So when we look at this one, we again see parentheses. It should again draw us to do something there first. Nothing to do inside that parentheses. 4x minus 8 can't be combined. There is something being done to the parentheses. The parentheses is being multiplied. However, here I would warn, the parentheses is not being multiplied by 3. Being multiplied by a negative 3. So the 9x doesn't change. We'll leave that there. Negative 3 multiplies the 4x. Negative 3 times 4x is a negative 12x. And then this is negative 3 times negative 8, which is a positive 24. Now I'll keep combining there. I have 9x and a negative 12x is a negative 3x plus 24. On the right side, the 9, there's nothing to do to the 9, so that just stays as it is. Now we've combined everything we can combine. Variable is on one side. We'll start to solve. Positive 24, so we're going to subtract 24. That's gone. Negative 3x. On the right side there, 9 minus 24 is a negative 15. And now we get rid of the negative 3 by dividing by negative 3. X equals 5. So the key there was to remember that this is a negative 3 that multiplies the parentheses, not just subtracting a positive 3. Similar to that, but I think a little trickier to recognize, is this problem. So when we look at this one, see the parentheses, and we see that there's nothing to do inside those parentheses. We look outside to see if there's anything that's being done to the parentheses, and at first it looks like there isn't, but there is. This minus sign in front of the parentheses. You think about if we had just x plus 7, that's really a 1x plus 7. We just don't write the 1 because we don't need it. The same is true here. This minus in front of the parentheses, there's no number written there, but there's one that actually is there. The 1. It's a -1 times what's in that parentheses. So when we see that subtraction in front of the parentheses with no number there, we have to treat it as -1 times the parentheses. So here the 2x isn't going to change. We'll distribute the -1. -1 times 5x is a -5x. And -1 times 1 is a -1. 4 to combine there on the left side, so we'll keep going. 2x and -5x make -3x. We'll have the -1 equals 14. And now we're ready to solve. So we'll add 1 to both sides. -3x equals 14 plus 1 is 15. Divide by -3. X equals 15 divided by -3 is a -5. Well, let's keep going with this. Make it a little more difficult again. Let's do 4 times 5x plus 3 minus 2, 3x minus 4. So here we have multiple sets of parentheses. Just like order of operations, we are going to go left to right. So the first one on the left here, there's nothing to do inside there. So we look outside, it's being multiplied by 4, so let's do that. 4 times 5x is 20x, and 4 times 3 is a positive 12. The next set of parentheses, nothing to do inside there either. So we look to see what needs to be done to it. It is being multiplied. Again, we have to be careful. It is being multiplied by a -2. -2 times 3x is a -6x. And -2 times -4 is a positive 8. That equals 62. We're still combining on the left side. We have 20x and -6x. Positive 20 and -6 makes a positive 14x. Positive 12 and a positive 8 is a positive 20. Now we've combined everything we can on the left side. The right side is still just 62. The variable is already to one side, so we are ready to solve here. Subtract the 20. 14x equals 62 minus 20 is 42. And then divide by 14. X equals 42 divided by 14 is 3. Something like this. Again, we have to be careful with the negatives. But let's go through it step by step. So going left to right, this is our first parentheses. Nothing to do inside of it. So we'll multiply by the 2, giving us 10x minus 8. Second parentheses, nothing to do inside there. Again, it appears that there's nothing to do outside, but that minus in front is really a -1. We have to multiply that parentheses by a -1. So -1 times 3x is -3x. -1 times 2 is a -2. Still equals 4. We'll combine 10x and -3x is 7x. -8 and -2 is a -10. Still just the 4 on the right side. Now we're ready to solve. Add 10. 7x equals 14. And divide by 7. X equals 2. Let's have you guys try one in your notes quick. Yes, I am writing all the way over to the left side for a reason. I'm going to give you a little bit of a monster here just to prove that it's really not that much more difficult. Give you a couple minutes to do that, then we'll go over it. Might not be completely done. Let's go ahead and take a look, see how you're doing. So again, we're going to combine what we can on each side. Starting on the left side, first parentheses, nothing to do inside, so multiply by the 3. 3 times the 5x minus 1 is 15x minus 3. Second parentheses, nothing to do inside there, so we're going to multiply by the negative 2. So negative 2 times 3x plus 4 is a negative 6x minus 8. Now before we move over to the other side, we're going to keep combining more. There's more to combine on the left side here. 15x and negative 6x is 9x. Negative 3 and negative 8 is negative 11. That's everything we can combine on the left side. So now we'll go over to the right side. On the right side, first parentheses, nothing to combine. So we'll multiply by the 5. 5 times 2x plus 7 is 10x plus 35. Second parentheses, again, nothing to do inside there, so we'll multiply by the 2. 2 times x minus 3 is a positive 2x minus 6. Then there's the parentheses ends there, so there's no more multiplication, so there's nothing happening to that 2 quite yet. So there's still more to combine on the right. We have 10x and 2x make 12x. 35 and negative 6 make 29. And then combine that with the 2 is a positive 31. Now we are ready to go ahead and start solving. Sorry, not solving. We get the variable to one side. There's an x on either side. We're going to get rid of the smaller one, which is the 9x. It's positive, so we will subtract 9x. So the 9x is gone on the left side. We'll subtract 9x from the 12x on the right side. So we've got negative 11 here. 12x minus 9x is 3x. 1. And from there, I'll go through this really quickly because I know you guys can solve it from here. Subtract 31 to get negative 42 equals x. And we divide by 3. Get negative 14. A little bit of a different spin might look like this. X squared minus 3x plus 7 minus x squared minus 4 equals 7. Well, when we look at this one, we see the x squareds and we start to think, well, that's a problem. We don't know how to solve it with x squareds. But let's go back to our combining polynomials. This is x squared minus 3x plus 7 minus, we have the x squared. There's no x, so there's put in a 0x minus 4. And we are subtracting. So let's do that subtraction. 7 minus a negative 4 is a positive 11. Negative 3 minus 0 is still negative 3x. X squared minus x squared cancels out. It's gone. So we have negative 3x plus 11 equals 7. So that reduces to one of our simple equations that we don't solve. I'm not going to finish solving that because I'm going to assume you guys can do that at this point. We can run into equations with fractions. They might start out as simple as 3x minus 1 divided by 4 equals 5. Here, that fraction bar, remember it's an enclosing symbol. It's telling us what was done to my variable here when this was put together. It was x was multiplied by 3, then the 1 was subtracted. It says we have to do everything on top first, then it was divided by 4. So it's just a third step in building this equation, which means we have a third step in taking it apart. So the last thing done was multiplying by 4. First thing we're going to do, dividing by 4. So the first thing we're going to do to take it apart is to multiply by 4. That'll remove that dividing by 4. On the right side, 5 times 4 is 20. So on the left side, we multiplied by 4. All that did was remove this dividing by 4. We're left with 3x minus 1. Again, this is now an equation we know how to solve. Add 1, 3x equals 21, and we divide by 3. X equals. You can run into equations like thirds x plus 3/4 and 1/8. We can go ahead and just work with the fractions. Subtract 3/4 here. That go away, subtracting 3/4 here. 2/3 x equals. Now I could write it off to the side, 2 and 1/8 minus 3/4. I know that is 1 3/8. Now we have to divide by the 2/3. Thirds is gone, x equals. Now I do have to do the 1 3/8 divided by 2/3. That one I do have to write out. Can't do that one in my 1 3/8. Got to make it improper. 1 times 8 is 8 plus 3 is 8. Multiply by the reciprocal, so times 3/2. 33/16, or 2 and 1/16. But we could have taken an equation like that. 2/3 x plus 3/4 and 1/8. And rather than working with the fractions, we could have got rid of the fractions. You guys have looked at least common denominator. Here we have denominators of 3, 4, and 8. The least common denominator will be a 24. So if I multiply that whole equation by 24, it'll get rid of all the fractions. Let's do that. 24 times 2/3 x, 16x. 24 times 3/4. 24 times 2 and 1/8 is 51. Again, you might have to do a little bit more work multiplying those out, but you'll get to that equation, and now it can be solved without any fractions. Back to 18, 16x equals 33, and divide by the 16. And x equals 1/16. Now, a little trick here that I used at this point here, when we're dividing to solve these equations, if it doesn't divide out to a nice even whole number, remember that division and fractions are kind of interchangeable. We can take 33 divided by 16 and do exactly what I did here, turn it into 33/16, and just reduce that fraction, 2 and 1/16. Now, the reason I showed you this last method here, because there are equations we will run into where we have no choice. Only way to solve them will be to find a least common denominator of some sort and multiply. Like this equation here. 3 plus 2 over x plus 5, 6 equals 5 over 3x. The only way we can solve that is to find a common denominator and multiply it out. Here we have denominators of x, 6, and 3x. Smallest number that we have basically here is a 1x. So we have 1, 6, and 3. The smallest number for the common denominator would be 6. For variables, we just take the largest power of the variable. Well, there are no powers other than 1 here, so x is just x to the 1, or just x is the largest power. So 6x would be the least common denominator. So we would have to multiply this whole equation by 6x. Doing that, 6x times 3 would be 18x. 6x times 2 over x would be a positive 12. 6x times 5, 6x would be 5x, or 5 over 6 would be 5x, equals 6x over 5 over 3x is just 10. Again, that has been reduced now to an equation that we know. Okay, so a couple of comments. Test 1. I have received test 1 and graded from Clear Lake and Mauston. Clear Lake and Mauston, you guys should be graded in the books, and it should be back at your school. Someone at your school should have that. If you go ask them, they should be able to get it back to you. Clayton and Durand, I have not got yours yet, so get a chance, ask your contact person. If you finished it, ask your contact person, make sure that those are sent out. I have not received them yet. So if they tried to send them out, they did not come through. So please double check with them and have them send it out again. A note on scheduling. This Friday, February 11th, I think 6 out of our 11 students do not have school, so there will be no class this Friday. I will send out a message to your people too, so they know that there won't be class Friday. Just ahead. For now, our homework from today. Look at page 49 through 50. Problems 1 through 43, the odds. And solving equations. On Wednesday, we'll start to take a look at what are we going to use these equations for. Biggest thing we're going to use them for, we're going to do a little problem solving, but the biggest thing we're going to use them for is for solution mixtures and those types of problems. With that, that's our time. So you guys have a great day. Hopefully we'll see you all on Wednesday.